Hi, I'm Martin and welcome to Turtle JavaScript. Today I will cover 5 easy steps to master carrying and higher order functions in JavaScript. To skip to any section that interests you, you can find the time markers in the description. I have also linked in the description the text version of the video. You can find there all the code and resources that you may need. Carrying and higher order functions represent the basics of functional programming. Because JavaScript directly supports them, they can turn your code into pure magic. They can have a notable positive impact on improving the reusability and performance of your code through functional programming. One of the functional programming features of JavaScript is based on the fact that functions are first-class citizens. That means that functions can be passed or returned as values like strings or any other type. These are some very basic examples demonstrating that functions are first-class citizens in JavaScript. If you look at the first one, the arrow function, I simply give it an input and it returns the same input out. Then when I call it and I give it input value, it will simply return value. That is what we call identity in functional programming. The next function is my function as output. It doesn't take any input from me, but it will simply return first class type again. So when we call the function here with first parenthesis, it will return first class type. So I can call it with value as I did above, and it will return value. Clever, right? The next one is my function as input and output. So it's a function that takes input function and returns the same input function. So in this example, when I'm calling it, I can give it first class type as an argument and it will return the first class type here. And then I can call first class type with a value, which will then return a value. And if you are looking well, you can actually notice that this and this are both identities and they are the same thing, just written differently. So I can also call first class type, give it first class type, and then call value on it, and it behaves in the same way. A higher order function in functional programming is simply any function that takes a function as an input or returns a function as its output. Therefore, all the functions in the previous example were higher order functions. The nested returned function always has access to the scope of its parent function, which you can also use to write functions like in this example. This is a simplified and more verbose implementation of the memoization function from Turtle Lambda. Memoization is a functional programming optimization technique that uses memory to skip computation by directly looking up the result in a key value map. When we define a function uppercase, we do it by calling memo and giving it our implementation as its first argument. When we look at memo, you can see that it returns a function. So this whole piece returns a function which is stored in the uppercase variable. And this allows us to call it as if it was the original function, but it is actually wrapped in memoization. So on the repeated calls, it will look up the value in memory instead of calling or evaluating it. You can see that this is also an example of argumentless or point-free implementation. You could also write it as uppercase here, where you make it more obvious that it is a function to which you will be giving a value. And you call it the same way. So these two are pretty much equivalent. You might easily think that carrying got its name from your favorite curry-based cuisine. However, you would be very wrong. Carrying is named after the mathematician Haskell Curry. His combinatorial logic research, together with the lambda calculus of Alonzo Church, created the foundation of functional programming. The functional programming Haskell is also named after Haskell Curry. In the previous examples, you might have noticed that we have been using multiple function calls by having multiple parentheses with parameters in succession. This is also how you would call a carried function. In this code, you can see two equal functions, carry1 and carry2. Carry2, written by using an arrow function in JavaScript, is certainly shorter and easier. Each arrow in the arrow functions returns everything defined after it, and you can use as many arrow functions as you want. Carrying is simply the process of replacing an nary function with multiple arguments to a sequence of functions, like in this example. We have unary function here with just one argument, so simple arrow function. We have binary function here, so binary to array function with two arguments, and then in carried way we have two arrow functions in a succession. And a ternary function, abc, we have carried here, and we simply call them being equivalent. So both of those calls produce 6. In functional programming, we always prefer creating functions with the arity 1, unary, that have only one argument. When I write my code, all my functions are always carried. I'm talking about unary function because this is unary and this is unary. So there are two unary functions which created carried binary function. Carried functions are great because they are made to be reused or combined to create other functions. In this example, we carry functions filter, roll case of, and includes, which are functions from JavaScript. We then define the function isTortoise through function composition. Building of filter tortoises is then as simple as putting Lego pieces together. This style of writing code also follows the best practices of KISS, dry, and single responsibility principle. This, in addition, also makes it much easier to test your code because you are left with small atomic pieces that are fully inspectable, without any black boxes or shared side effects. Because carrying native JavaScript functions every time that you want to use them is annoying, it is much better to use a library like Turtle Lambda that already does everything for us and even gives us a very useful compose function for our composition. The final code then looks as elegant as this. In this example, you can see that on one line we can define isTortoise as a memorize compose point3 function, and on the next line we simply define filter tortoises by using that function. And this is the same that you have been seeing in the previous example. Writing code like this takes a little practice, but it is magic. Apart from making your code more reusable and shorter, it will also become much easier to understand and argue about. To do the same thing, using just native JavaScript in imperative procedural code, I have been able to write imperative filter tortoises on 17 lines. If you want to compare characters instead of lines, the functional declarative code took 115 characters, and the imperative function needed 515. You may want to be able to just use a function that magically transforms your nary function to a carried function or allows your function to be called in either way. For that purpose, I am giving you the function carry that takes nary functions and function nary that takes carried functions. Both will allow you to call your own functions either way, as carried or nary. Notice that the functions carry and nary themselves are written declaratively in a functional programming style. You can learn more about imperative and declarative programming in JavaScript in one of my other videos. Here in the example, you can see how we use those functions. So, similarly as with function memo, we give them your function as an argument, and then you can call either of those functions in either way that you like, and they always return the same thing. Both functions are of course available for you in the Turtle Lambda library. In fact, Turtle Lambda uses the magic of nary function internally to allow the consumers of the library to call all the functions either way as carried and nary functions as well. After learning functional programming in JavaScript and using Turtle Lambda, I would never want to go back. After years, I still sometimes stop and admire the simplicity and elegance of the code that you can create this way. My hope is that this video will put you on a road that will allow you to get the same intoxicating experience. Let me know in the comments if you have been writing functional code yourself, or if you have experience bringing these principles to your team. That's everything for today. Thank you for watching the video and see you again next time.